The idea is that the quasars that we see that look so bright are not the black hole, the supermassive black hole. They are the gas that's just about to fall into the supermassive black hole that's going around it, shining very brightly just before it disappears down the black hole.
A giant black hole would have a gravitational pull so overwhelming it would hurl gas and stars around it at almost the speed of light. The violent clashing would heat the gas up to over 1,000,000 degrees.
The gas rubs against itself, essentially, and gets extremely hot. And extremely hot gas shines very brightly.
In reality, a quasar burns so brightly it's impossible to see the black hole in the middle. Its hole is made invisible because it swallows light. So for years, no one could be certain if supermassive black holes really did exist at the heart of these strange, active galaxies. An elite group of scientists called the Nuker Group have spent the last 2 decades hunting for these elusive monsters. The first problem they faced was to prove that supermassive black holes existed at all. What they were to discover would be stranger than most people could have imagined. One of the first of the Nukers to try to find one was Alan Dressler. In 1983, he came to the Palomar Telescope in California, convinced that he'd found a way to prove that supermassive black holes exist.
You can't see a black hole directly. That's what makes it a black hole. So what you're looking for is evidence of its gravity. You're looking at how it pulls on the stars that are coming nearby.
Dressler knew that although a black hole is invisible, its immense gravity would hurl stars around it at over 31,000 miles an hour. By measuring how fast these stars are moving, he can prove if there really is a black hole at the center of an active galaxy.
I picked a galaxy nearby, which is called NGC 1068, an active galaxy, which meant that it probably had a supermassive black hole in it. At least that's what we wanted to prove.